Hi everyone. I believe you can see my screen and you can hear me. Maybe we'll wait several seconds just to everyone can join us, and then we can start. Okay, so then let's go. My name is Roman Kondur. I'm a senior engineer of SDC Verifier, and today I would like to present you topic structural verification for the ship design based on the ABS and DNV standards. So let's start from the introductions. I'm going to turn off my camera just to make smooth connection. So let's do it, and we can go to the introduction itself. Okay. During this topic, we are covering the short introductions about the SDC itself. We will focus our attention on the engineering problems with the ship design. We will show the possibility of the SDC Verifier, how to build the model, how to perform checks according to the standards. We will show the informations about the recognition modulus, and then we step by step show you how to conduct the verification according to plate buckling with the DNV and ABS regulations. The second topics about the verification will be Welds Fatigue Verification according to DNV, and assign the weld classifications responsibly. After that, the report will show the information about the report designer and the general workflow, how SDC works. The last one topic will be about the SDC SAM. So this is new product which we developing right now, and at the end we sum up everything, and after that I think you can ask me about some we will have the Q&A session, and you can fill in the chat in the chat box your questions. Okay, so I think we can start from the introduction. The SDC Verifier was founded in 1998 by our CEO, Walter Wandebos, who is the technical teacher in the university in Delft. It's our company was founded and contains only one person, but we are continuously growing. Right now, we are more than 30 people in 3 different offices in the Ukraine, Poland, and the headquarters in the Netherlands. So, based on the engineering experience and knowledge about the standard verifications, we start develop our own software, which called the SDC Verifier, and that makes sense because, as you know, the standard verifications require the preparing the repetitive and boring work. So in this case, SDC Verifier help you to reduce time to execute the structural verification in according to standard regulation. Based on the past 10 years, we conduct the more than 250 engineering consultancy projects, and our SDC software using more than 200 people around the world. So as you can see, this is quite a big numbers, and we are a reliable company who can conduct the engineering consultancy service. So let's go to the next and start talking about the problems in the maritime structure, maritime industry. So in the maritime industry, engineers are faced with the two common challenges. This is the plate buckling and the fatigue cracking. Plate buckling occurs when the structural plates are subjected to the compressive stresses, which can lead to the deformation, to the local and sudden deformation, and it can be subjected to the high risk during the operations. The fatigue cracks can involve progressive damage for the repetitive loading over the time. So both these issues require to be carefully checked and carefully and attention during the ship designer, as well as when we do the FEA verification, we take into account the standards requirements. So in order to be sure that your design are safe enough, I would like to present you SDC Verifier software. So on this slide, we can see the SDC Verifier window, and from the right side, you can see the main functionality, what can be done with the SDC Verifier. First of all, what we can do here, we can build our geometry from the scratch. We can import if we would like to import our geometry from the designer programs. This is not the problem, as this is support various of the extensions for this. So our geometry can be simplified from the step model, or it can be built from the scratch. Then this geometry can be meshed, and beam, plate, and solid elements can be used for this structure. Then, in order to execute the verification, we can recognize our structural members. That's in this case, this is plate, stiffeners, and so on, welds. We can assign loads constraints in our model and do verification which take into account sim center and strand solver. In order to do the standard check, we have extensive library, and I think each user can find our proper standard for them. After that, when we did all this step, we can grab all this information in the report design. We can open our report designer and put all this information and generate it for the complete view what we did and what the results of our structure. On the next slide, you can see that this is the most usable standard around the world. So we can see that this is AIC, Eurocode, DNV, DIN, ISO, VDI. So SDC contains more than 400 standards, and for the different verifications. So it's not like focusing on one type of the elements. It can be executed for the beam model, for the beam structure. It can be executed for the plate structure. So you have choice what kind of the verification need to be executed. On this slide, I would like to show you the specific loading, because in SDC Verifier for sure there is like standard ways how to apply loads. We can apply our loads to the geometry, points, lines, surfaces, as well as to the nodes or elements. But in order to reduce time of the applying loads such as buoyancy, tanks, or wind, or even like even distributions of the wave, SDC has it automatically. So we need to predefine some general characteristic of, for instance, of the wave. We need to predefine the height of the wave, and SDC automatically will do it by us. So this is really time saver and important things to speed up your engineering process. After that, when we apply our loads, we need to go to the next step. We need to predefine our load combinations. So in SDC, this is really simple because there are several options how to deal with. First of all, we can prepare our load combinations in the spreadsheet, and after that simply copy and paste it in the SDC Verifier, or we can also use our predefining load combinations, which can speed up your process of the preparing load sets. Then when we like prepare our load combinations, we need to recognize our structural members. And then we go to the next slide, which shows us information about the recognition tool of the SDC Verifier. So on this slide, you can see that 4 types of the recognitions we can conduct. The first one is the joint finder, second one beam member check, and 2 last are important for us for this session since we are going to cover it in detail. So the first one is the weld finder, and it allows us to recognize all the welds in our plate structure, and also recognize panels, plates, and stiffeners if there are, in order to conduct the DNV verification. So basically, that's how it looks, our step by step, what we need to do. First of all, we need to prepare our model, we need to apply our load constraints, then we create load combination in accordance to the standard, which take into account the partial safety factors, dynamic factors. We recognize our members, and then we will conduct the verification. So this window shows us the recognition ribbon, and here you can see there is several options to recognize our structural members. We can simply press recognize all, and SDC automatically recognize all possible structural members in our model. Right now, this video represents that we are recognizing only plates, sections, and panels here. And for this model, as you can see, this is really time, how much time we need to recognize it. It's almost 40% already recognized. So that's the main window of the panel recognitions, and here you can see the information about the sections. So our sections can be in X, Y, Z, and custom sections, and these sections can contain the panels, plate, and stiffeners. So it took, I would say, maybe in order to recognize all the panels and all the plates, it took around 1 minute for this complex model. So I would say this is not really long time for that. By the way, during the recognition of our sections, we can after that play with the checking them, and also we can highlight them with different color. what I would like to show you right now. So if we go to the section X and highlight them, you will see that we highlight all the frames in the X direction. So all these sections which normal to the X directions are highlighted and recognized in the way that we recognize our section, that then our section divided by the panels, and our panels then divided into plates. So all the plates are automatically recognized. We take into account proper distance, proper geometrical characteristics like width and length, and also we extract information about the plate thickness in order to have the complete pictures of it. So that's information about the panels which we recognize in the X directions. Then the same logic is for the Y direction. So we show all the panels, all the sections which lies in the normal to the Y global coordinate system. Then we can highlight our sections and panels in details. The same things is for the decks. As you can see on these pictures, we can find out information about the sections. We can highlight information about our panels and see also the ID numbers in case if we are specifically focusing on this plate or panel. Okay, so let's go to the next, and here this is quite interesting because previous slides shows us the sections which are aligned in the global coordinate system, but yeah, don't be worried about the surfaces which are aligned in not global in the like inclined directions or inclined surfaces. So we can also automatically recognize it, and this is the proof of it. So it's called the custom sections, and in the custom section we can also recognize our members. Okay, so after that, when we recognize all the panels, plates, and stiffeners, we need to go to the standard window and add the new standard to be verified. So from the left and right sides, I show the two wizard window of the standard, which should be predefined before the verification. So let's walk through this in details. I would say this standards DNV and ABS quite common because the logic is the same. We take into account our compressive force and compare it with the resistance, which based on geometrical characteristic of the plate. So first of all, I would like to focus your attention on the resistance material factor. So this in the DNV by default is 1.15. In the ABS it's 1, but it can also be adjusted by this by these choices. Then we have material with yield. That means that if we have 0 from both sides, that our yield is properly assigned, and here is like explanation of it. These options present for the both standard, this here and here. Then we see the selection, so we can conduct our verification for the portion of the model, so we don't need to calculate full model if we know for sure that everything fine for the rest of the structure. We can specifically focusing on the some proper location for us. Then we have the thickness factor as well as here. That means that in case if we would like to take into account some extra thickness, we can increase it, or if we know that our structure with it's not in the fine conditions, there is some pitting or corrosions, we can reduce it in the percentage ratio, and it allows us, I would say, without changing our model, estimate the level of safety for our structure. Then quite important and main aspect of the buckling verification, that what methods we are going to use. There is like two options. We can use the plate average method or elemental method by clicking this checkbox. The same we have for the ABS. And what the reason of it? If we are going to use average plate, then we are focusing our attention, and we will receive the result on the plate itself. So we receive the results just to estimate global buckling of our plate. While if we uncheck this checkbox, we will focusing on the elemental method, and it allows us to select two sub methods. I slightly zoom in just to show it to you. So if we select elemental methods, we will have possibility to conduct two different approaches. First one is use the average element stress. So we will going to sum up our stresses and divide it by the area. And another one, this is like find out the minimum element mid-plane stress, which result into membrane stress, and it allows us to calculate plate buckling without the local bending. That's about the average and elemental method. So elemental method allows us estimate, I would say, a local effect of our loading, and yeah, that's also good to know and have a possibility to check the global and local effect on our plate. Then what we can do here, we can also include the calculate our shear load as absolute value. So in this case, we will consider the conservative scenario of the shear loading. Probably, yeah, that's about the plate setup. Yeah, I think that's it. And about this stiffener buckling. So if we have stiffener in our structure, SDC also can perform the buckling verification, but we need to predefine the C factor. So this factor means that as ratio between the smaller and larger design stress, SDC will calculate it automatically. And this is the distance. I see that this is arrow on my slide, but it can be adjusted. So this is the distance. This is distance between the natural axis of our stiffener till the bottom flange of the plate. So this distance can be also automatically determined by SDC, and you don't need to fill in all this information manually. So basically, that's about the setup of our standards for the buckling verification. Then what we can do, we can see the result for this, and for all these slides with the results, I show you the results for both standards, so we can compare the results for the same sections, for the same panels and plates. As you can see here, the results quite comparable, and for sure it cannot be the same since different standards required different load combinations, partial safety factors, and also we need to know that different material resistance are used for both of them, which we talking about it previously. So this is results for our frames. Then we can go to the results of our longitudinal panels. As you can see here, that's highlight almost the same locations. Then we can see the results of our decks. So decks, according to ABS, showed the slightly better results, I would say. And the last one slide with the result, this is related to the custom sections. So as you can see that we are safe with these results, and everything dark blue, so that means there is a lot of reserve capacity for this structure. Okay, basically this is above the buckling verification. We take into account the SDC Verifier, and I think we can go to the next like subtopics verification of the fatigue. So let's go to the next one slide. And here, this is also short video which allows you to see how much time we need to recognize all the welds for this complex structure. So this window represents our weld finder. We can press in one click, press find, and it will be automatically recognize all the welds in our structure. For sure, there is options what we can adjust before the recognitions. We can play with the selections. We can adjust non-welded properties. For instance, for the rolled section, we can edit, combine, and so on. We can edit, remove, or combine our welds. So that's also extra benefit. So we can make some modifications with our welds. We can highlight them just to visually check it. And that's the list of our welds on this screen. So let's go to the next slide, and we will see how we can highlight them, how we can present them. Basically, here you can see that all our welds are recognized and can be highlighted in different colors. It shows you the information about each of welds. We can highlight them with the ID numbers, so we can in this way specifically focusing on those welds. Also, SDC allows you recognize automatically welded, non-welded properties. So basically, this is really important for the fatigue and weld strength check, because for the non-welded property, fatigue weld strength can be higher than for the welded property. So all this variation is possible with the SDC. By the way, I forgot to mention that all stresses in the weld are automatically converted from the local coordinate system of element to the local coordinate system of the weld. So we don't need just do it manually. So SDC do it by us. Also, what important to know that SDC can recognize all weld intersections, since the weld intersections are the weakest point in our structure. And with these recognitions, we can predefine the lower weld quality for those zones and properly estimate our fatigue level for them. The last one, options, which I would like to mention, that for the rolled sections, as shown here, for instance, I-shape, we can exclude welds between the flange and web, while the rest welds are properly recognized. So that's about the recognition. And the next, what we are going to do, we are going to cover the step how to predefine the standard for the DNV Fatigue Verification. So this one at the middle window shows us the wizard window of the fatigue standard. And here we have 4 options which need to be redefined before the conduct the verification. Basically, from these descriptions, you can also find out information where it came from. We have referred per each chapter. So the first one is the environment, and that's basically related to the SN curve for the different component, for the different like environment of our structure, whether it in the air or in the sea. We are going to use different SN curves. So by the component, we can adjust it and apply the proper environment for our structure. The next one is the reference thickness. So by default, this thickness equal to 1, but we can adjust it by applying the tubular or not tubular. So SDC will automatically calculate this distance for us. So that's about the reference thickness. And then the next option is SN curve. That's about the calculation of our delta stress with method B. If we press yes, if we include this method, we involve the extra factor for our delta stress 1.12. So if you would like to include it, you can do it. So that's like also possible in the SDC verifier. And the last one, and quite important characteristic of the fatigue, is the notch classes. So in SDC we can assign different notch classes per different directions in the weld directions, perpendicular to the weld directions, and shear. All this data based on the standard table. So as you can see here, if we compare the B1 with this one, B1, that means the weld strength for the material which doesn't contain the welds will be equal to this characteristic. So all this information can be taken from the appendix A of our weld classification. Then I would like to highlight our weld recognition, because this is really important for the verification. So on this slide, you can see in detail how it can be predefined and how we can visualize this and check by ourselves how it looks like. So basically, we highlight weld strength in X direction. So that means this is along the weld. And here you see that for the complete structure, we have the B1, which has the higher weld strength quality of the material. And then for the all welds, we assigned C1. This is along the weld in yellow color. And for our weld intersections, which has the lowest quality, we assign the quality D. So in this case, our intersections will be checked with the lower quality, and it allows us estimate as the fatigue level as precise as possible. So this fatigue classification is conducted for the all directions, for the parallel to the weld, perpendicular, and to the shear. The logic is the same, but we have like different weld strengths highlighted here. So for the y directions, for the y directions, and for the full model, we have the same B1. For all welds, we have quality D, and for the shear direction, we have quality E. So that's about the fatigue classification. So as you can see that all this table based on the standard, and we can highlight it just to check it if everything is properly recognized. Then we can go to our results, and here I would like to present you information about the results. So SDC has various options how to present them. We can present with the full model, we can present with the only our welds. So from these pictures you can see that where we have our welds, it's like more it show us the information that our strength is lower and results are higher for those locations. But if we are focusing at the location where we have intersection, for instance here, you see that the results much higher compared to the nearby zone, and this looks reasonable since this location is stress concentration point, and it can lead to the higher stress and delta stress value for those locations. So this is general pictures and informations about the fatigue verification for the ship structure. So after that, when we conduct the all these standards and check our structure according to regulations, what we can do, we can prepare the reports. We can prepare results report to present our results for panels, plates, stiffeners. We can prepare our report for the fatigue verification. Besides that, it's also possible highlight what load set and constraints are assigned to our model. So SDC allows you execute two types of the report. This is the model setup and results report. So you can collect all information about your calculations and store it in your engineering library or deliver directly to your client. So everything can be stored, and during the time you can easily to check it and find out information what was done in this project. Okay, so let's go to the workflow of the SDC Verifier, and I would like to pay your attention on this circle. So this is really important to know, and it shows you what the benefits of SDC Verifier using. First of all, we start from the simulations. Simulations allow us to create our FEA model, apply the individual loads, boundary conditions, and calculate our model. So that's possible with SDC. Then what we need to do, we need to predefine our load combination based on the standard requirements. After that, we go to our recognition. We recognize our structural members, which we would like to verify. Then we do the code checking according to the standard and automatically prepare the report for our structural members, components, or FEA model. So that's how it works. You can see also here arrows. This is done on purpose. So what that means? That means that all these steps are automatically stored, and you don't need to redo it several times. For instance, if you know that your model is slightly changed, you change maybe thickness of your model or some load magnitude or some constraints. What you need just to do, you just need to adjust your model, recalculate it, and press generate report. So all this intermediate step will be done by SDC automatically. So this really convenient way how to speed up your process, because from time to time, on Friday, for instance, we have some slight modifications, but to do all these steps is really time consuming. But with SDC Verifier, we slightly adjust our model, recalculate it, and just simply generate report, and all these modifications will be automatically taken into account. Besides that, SDC contains optimization modulus, which allows us to calculate the optimal result for us. For instance, that can be related for the beam member cross section, that can be related for the weld geometry, what kind of the weld, fillet, full pan weld, or partial penetration. So it can be possible to find out. We can also optimize our plate thickness based on the buckling verifications, or calculate the optimal yield limit for our steel structure. Okay, that's basically about the steps of the static verification according to DNV and ABS codes. And I would like to announce one more additional things for you. So as I know, we have three slots for the demo, and as I see that for the three first people who are going to register right now, we will conduct it for free. And I think there is also possible way that you can share your FEA model or a step model. We can do it on your model. So basically, it wouldn't be not just like simple demo. It can be like I would say event training. So with our engineers, step by step, we will show you how to prepare the FEA model, how to adjust your load combination in SDC, and recognize structural members. Then we will show you how to predefine it. How to predefine the standard itself, and prepare the short report for your structure. So please don't waste your time, and register by the link which will be shared by my colleagues in our checkbox. Okay, so basically that's about the buckling verification and the fatigue verification for the ship structures. And the last subtopics which I would like to present you, this is something new, I would say, but really important and crucial for all types of the structures. So this is SDC SAM calls. What that means, if we conduct the verification for the steel structure, I would say this is not enough to see the global pictures of our structure, and to know how much time it can be operating. So for this purpose, we're developing our software. Which allows us, based on the FEA calculations, receive the peak points of the structure, check them during the inspections, and after that, tracking in real life to see the global pictures of this structure. So also this is really important if we have not new structures, since the old structures required regular maintenance and verifications, but with the using SDC SAM, it becomes really comfortable to track the stage, the structural state, and then we can see how long it can be operated. So if we go to the next slide, we will see information about our assets, and here will appear the information about what kind of the asset we would like to see. We can see the name, we can see department to which belong it, we can see the addresses, and then we can go to the detailed information. If we press details, we can go to the asset itself. Here on this screen, we can see that we can find information about the location of these assets. We can find some general pictures or general photos, how it looks like. We can see the statistic data of the risk level and the damage type. So that's allows us to estimate the asset conditions. And also we can find out the information about the further inspection. So it would be even automatically inform you by the email. So for instance, in the half of year, we need to conduct the extra inspection for these structures. So basically, that's the main logic of this asset management tool. So if we want to know the more detailed information per structural components, we can go to our components, see informations about structural components in detail. So here we can see that we have boom, bridge, pylon, and so on. We can see that what the maximum utilization factor came from the FEA calculations. We can see the health status, last inspections, and days to the further inspection. So this is the global pictures per the subcomponents, I would say, but it also possible to dive deeply and see information for one components. And if we go to this slide, here we will see the part of our crane or our structure, which highlighted in different colors. So this is like navigation plot, which allows us to see what the part we would like to track. Then some statistic data about the risk level and information attached during inspections, some comments, some photos, files, or maybe some NDT inspection can be also attached to this component. Then if we go deeply, we will see more detailed information about the part of the previous component. We will see how many panels, structural items, or bolts it contains. And yeah, we can go deeply and gather more and more information about this structural component. So if we go down, we will see the panel. This panel contains 3 welds, 5 plates, and 3 stiffeners. So this is the general info about the panels. And here we can also go deeply and see information about our welds. For our welds, we see what the maximum utilization factor was based on the FEA calculations. We can fill in data about we can see the data about the damage, what was found during the inspections, and the last inspection date, a date before the inspections. But also for this weld, we see that we have 3 points of interest or inspection points, which need to be checked during the inspections. And if we go directly to this weld 1, there will be detailed information about what utilization factor is used, what the material is used, what the thickness of the welded plate, information about the damages which were found during the inspections. We can see the original value, like original data before the inspections. Also, we can find out the pictures with the detailed photos for this location. So basically, this is like the levels of detalization for our structure. So with this software, you can easily track each component of your structure and automatically understand what the risk level and how long it can be operated during the time. So then we see information that we can also we see the ribbon with the resources, and here can be uploaded information about the reports, FEM models, drawing links, and PLM systems. So that's all will be possible with the SDC SAM. And the last one slide, this is related to the authorization. So for sure, we are going to have different roles for this platform, since for different roles we will have different access. For instance, inspection cannot see the all informations, while the admin can allow some permissions during to the inspection or share some information with the potential clients. So all this will be integrated as well in our web version. Okay, so I think, yeah, we cover everything during this session. Just to sum up all these topics, the SDC Verifier is are focusing on three main directions. This is engineering consultancy service. We provide our client with the quite excellent, I would say, the engineering service. We conduct the verification using FEA methods with the preparing the detailed reports which deliver directly to them. The second one is the developing our own software, which called the SDC Verifier, who help engineers and thus and maybe not even thus like speed up the process with the FEA verifications and make your life easier to by omitting the routine work. And the third one is that our developing team start working on the SDC SAM projects, which allows us after the FEA verification perform the dedicated inspection based on the peak point which were found during the calculations and track the structural status during the time. So basically that's it. If you have any questions, you can fill in the chat box. Okay, I see some questions there. Codes refer to the ABS and DNV. Yes, those codes, yeah, for the plate buckling, those codes refer to the DNV and ABS, and fatigue verifications refer just for the DNV. So that was the answer. Maybe any other questions? Wait. I also see the question, can the software recognize curved shells, plates, panels? Yes, it can. I think you saw it during the presentation that SDC recognize the standard surfaces which belong to the global coordinate systems, as well as the custom sections which are not lying in the global coordinate system. Okay, I don't see any question more. So I hope this session was interesting and useful for you, and we will see you in the nearest future by our tutorials or demos. Wait. I also see the extra question. The code refers to the ABS and DNV for the fatigue and buckling. As I told before, that ABS and DNV referred for the buckling, but fatigue, this is referred only for the DNV. So fatigue verification, this fatigue verification which was presented referred only to the DNV code, while the buckling was referred for both of them. Okay. So thank you for your time, and yeah, wait. Will it take corrosion always as per class rule? I think for the buckling verifications, we can take into account corrosion by the factor of the thickness, if you would like to. So that's also the case. Okay, I see one extra question. Does the software support with the any 3D or other softwares? It's important the export model or geometry. Yeah, SDC Verifier support different extensions for this 3D geometry. So I think the geometry from the most famous modeling project can be exported to the SDC, such as the Solid Edge, SolidWorks. We can use the step file. So I think that's not the problem to export design geometry to the SDC Verifier. Yeah, I see, but corrosion will be different for the various plate panels and per the class rule. Yes, I agree with you that corrosion will be different, but in case if you would like to take into account different corrosions by quick test, you can adjust like thickness factor for the several components. For instance, you can create a selection for this different component and then assign the different thickness factor for it. Yeah, I think. Okay, I think we don't have any questions, so thank you for your time, and I believe it was useful for you. By the way, I just remind you about that we have this free slots for the demo, when we can directly show you how to conduct the backend verification step by step. So please don't waste your time. Thank you for the attention.